in this video we're going to be doing 4 great calculus problems. The source for these is JEE Main. It's great practice for AP Calculus. I would say almost every problem that appears on the JEE Mains is harder than basically anything you'll see in AP Calculus, but it could just be my perception because the questions are very different. The topics that we're going to cover are tangent lines, related rates, and then implicit differentiation is going to show up quite a bit. So let's take a look. So the first question we're going to do is, so when it says numerical, it just means that you have to like punch in a number, an answer, rather than choose from multiple choice options. So numerical, if the tangent to the curve y equals x cubed minus x squared plus x at the point AB is also tangent to the curve y equals 5x squared plus 2x minus 25 at the point 2, negative 1, then the absolute value of 2a plus 9b is equal to. So that's like the weird thing about this test versus the AP exam, where like this test routinely will ask you for some strange additional calculation that you have to do at the end. I guess to like fit a form, or I don't really know. All right, so with this problem, we definitely have enough information to deal with that second curve, right? So y equals 5x squared plus 2x minus 25 at the point 2, negative 1. So I'm just going to deal with that. So y prime for that function, 10x plus 2. If we evaluate this at 2, we get 22. And then we can write the equation of the tangent line. So I always start out with point slope form. And then I'm going to rearrange it in this case because I'm going to have to compare tangent lines. So I'd rather have this in like an easy to compare version. So y equals 22x minus 45. So that's the equation of the tangent line. Now what I'm going to do is I'm going to go back to that first thing, and I know the slope of the tangent line is 22. So if I find the slope of this at the point AB, I should be able to work with that. So y prime for this curve, 3x squared minus 2x plus 1. And if I plug in a, I mean, we could have just done it with x, but it's probably better to do it in the context of the problem. So we do this. These should be equal. So that thing we just got should equal 22, which leads us to a little algebra problem. So it's a quadratic. You could use a quadratic formula if you don't want to think about it. I'm going to move everything to one side. I'm going to choose to factor it because it does factor. A lot of things on this often do not factor though, so be advised. I think we can do this like a plus 7 and minus 3, and that should equal 0, which means we now know 2 potential values for a. A could be negative 7/3 or a could be 3. I have to take these and plug them, since I need to know what a and b are, I need to plug them back into that first function, the x cubed minus x squared plus x function. I don't want to deal with negative 7/3, so I'm going to hope that the answer at this point is a equals 3. So I'm taking this, I'm going to plug back into that first function that we have. I just tried to highlight that, but I chose a very bad color. So I'm plugging in, it's going to be 3 cubed, which is 27, minus 3 squared, which is 9, plus 3. So that gives me 21. So my ordered pair is 321. Now what I need to do is I need to see what the equation of the tangent line at 321 is. So, and hopefully it's the same as the one that we found before. So we already know that the slope is 22. I mean, that's the whole premise. So it's going to be y minus 21 is 22 quantity x minus 3. I'm going to rearrange this. I mean, you might look at that and just be like, yes, no, that is the tangent line. But I'm going to do the work anyway. So I get this. Those are the same. So that is the tangent line, which means that this point 321 is the point AB. Now I need to find the absolute value of 2a plus 9b, because that's what it asked for. So we got this, which I think gives us 195. All right, so that's like a really good, interesting tangent line problem, I think, in my opinion. You know, five stars out of 5. Let's look at the next one. For the curve C, which is wild, it's the quantity x squared plus y squared minus 3 plus the quantity x squared minus y squared minus 1 to the 5th equals 0. The value of 3y prime minus y cubed times y double prime at the point alpha alpha, where alpha is greater than 0, on C is equal to. So there's a lot going on here. First up, it's the point alpha alpha, so I think we can actually just figure out what alpha is. So we know this. I'm going to take x equals alpha, y equals alpha, plug it in. So I get alpha squared plus alpha squared minus 3 plus alpha squared minus 1 to the 5th is equal to 0. It's nice that you have that alpha squared minus alpha squared because those will go away, but here we get 2 alpha squared minus 3, and then negative 1 to the 5th is negative 1 equals 0. So from there we know that alpha squared is 2. Since alpha is greater than 0, that means that alpha must be the square root of 2. So we've already solved like half, well, I don't know, sort of half of the problem. We know what alpha is. All right, we need to find 3y prime minus y cubed y double prime. Yeah, I don't know if I said that right, but that's what we need to find. So I need to find y prime, and that's implicit. It's like a lot of implicit. So we're finding y prime. So here goes. For the first thing, it's not raised to a power, so we can just do it, right? It's going to be 2x and then plus 2y dy dx, and then the derivative of negative 3 is 0. For the second part, we're going to need the chain rule. So we have something to the 5th, so that's 5 times something to the 4th, and then times the derivative of that thing. So the derivative of this thing will be 2x minus 2y dy dx, and then the derivative of negative 1 is 0. So this all should equal 0, and I need to figure out what's happening on this when x is root 2 and y is root 2. So I'm going to sub in. So at these values, I'm just going to like directly sub in here. I just replace every x with root 2 and every y with root 2. Looking at it now, there's definitely a 2 that I could cancel, which probably would have made my life a little bit easier, but I did not do that. So simplifying this, I'm not going to make you watch that. I got 2 root 2 plus 2 root 2 y prime plus 10 root 2 minus 10 root 2 y prime equals 0. Got to solve for y prime. So y prime is going to be negative 12 root 2 over negative 8 root 2, which is just 3 halves. So that's an answer that we're going to take with us, right? Because we're going to be doing 3 times y prime minus y cubed times y double prime. Since we need to know what y double prime is, we're going to go off to the races on that. What I'm going to do is I'm going to recopy what I got for y prime. I'm going to change all, well, you know, when I said I was finding y prime, I'm going to change all the dy dx's into y primes because it's just simpler. So to find this, I'm taking what I had, changing all my dy dx's to y prime. Instead of solving for y prime and then using like the quotient rule and going out of my mind, I'm just going to like take the derivative of this with respect to x, which will involve a lot of product rules, but we're going for it. So I'm going to try to color code this as I go. So this thing, the derivative is 2. Now we're doing this. So it's going to be a product rule. First is 2y, derivative of the second is y double prime, plus second is y prime. The derivative of the first is 2y prime, so that's 2y prime squared. So that's what we have there. Now we're moving on to this, right? So that's a product. I've highlighted them in different colors, but maybe poor choice. I am not a color theorist, I guess. I always make bad choices. They're not like different enough, in my opinion, but whatever. Here goes. It's going to be first. So 5 quantity x squared minus y squared minus 1 to the 4th. Derivative of the second. So the derivative of the second, derivative of 2x is 2. Then we need a product rule here. So first is negative 2y, y double prime. That's the derivative of the second. Plus second is y prime. Derivative of the first is negative 2y prime. So we'll get minus 2 quantity y prime squared. So that's the first half of the product rule. So that was first derivative of the second. Now we need to do second, which is the 2x minus 2y y prime. Derivative of the first, this will require chain rule. So we have 5 times, bring the 4 down, so 20 quantity x squared minus y squared to the negative first to the third times the derivative of x squared minus y squared minus 1. So that'll be 2x minus 2y dy dx or y prime, and then the derivative of negative 1 is 0. Okay, so this whole thing equals 0. I have to evaluate this when x is root 2, y is root 2, and y prime is 3 halves. So again, I'm just going to sub in everything. I'm not going to make you watch that. You can do that on your own, hopefully. We get this. I'm also just now going to clean up, and I'm not going to make you watch that either. So I ended up with 2 root 2 y double prime plus 9 halves plus 10 minus 10 root 2 y double prime minus 45 over 2 plus negative root 2 times negative 20 times negative root 2 equals 0. Okay, we clean this up a little bit more. I get 12 minus 18 minus 40 minus 8 root 2 times y double prime is 0, which means y double prime is negative 46 over 8 root 2. So I'm skipping a lot of arithmetic. Hopefully that's okay. It's really, that's just a matter of diligence, I think, and really like keeping track of things. It's not so much a calculus problem, which is why I'm okay with skipping it. So now I know y double prime is negative 23 over 4 root 2. Okay, where do we go from there? Remember, we're trying to figure out what 3y prime minus y cubed times y double prime is. So we know y is root 2, we know y prime is 3 halves, we know y double prime is negative 23 over 4 root 2. We're plugging in. So we're plugging into this. We get 3 halves, minus root 2 cubed, and then times negative 23 over 4 root 2. There's so many places you can go wrong on these problems, which I like. You know, I like sitting down and spending the time and working through them. But there's a lot going on. So 2 root 2 cubed is just root 2 cubed is just 2 times root 2. So a lot of stuff cancels here. We get 9 halves plus 23 halves, and that is 16. So that's our numerical answer on that. Good problem. You know, as I mentioned, like harder than I think anything you would ever see on the Calc AB or Calc BC exam. Great practice, however, because like a lot of those ideas are in there. All right, let's take a look at the next one. This is a related rates problem. So let's see. A water tank has the shape of a right circular cone with axis vertical and vertex downwards. So that's in the parlance of the AP exam. That would be an inverted cone. Its semi-vertical angle is arctan of 3/4. And then water is poured in at a constant rate of 6 cubic meters per hour. The rate in square meters per hour at which the wet curved surface area of the tank, that's the lateral surface area, is increasing when the depth of the water in the tank is 4 meters is blank. So we're trying to find the rate of change of that lateral surface area. Okay, so what do we got going on? I always draw half of the cone. And in this case, they actually gave us the angle for half of the cone, the semi-vertical angle, instead of the full vertical angle, which would be 2 of those. So this is theta, and we're told that theta is the inverse tangent of 3/4. All right, so now what do we do with this information? Well, what else do we know? We know dv dt is given. It's 6 cubic meters per hour. We also know that the height when we're like doing this is going to be 4. We're looking for the rate of change of the wet curved surface area. I'm going to call that ds dt, using s for surface area. Now, what we may not know is how to find the lateral surface area. So that definitely, if you, I don't know, if you grew up doing math in America, you probably didn't run into this, to be honest. Maybe you did, I don't know. The lateral surface area of a cone is pi times r times L, but what is L? L is the hypotenuse of the cross-section. So if I call this x, call this y, L is going to be this thing, square root of x squared plus y squared. So that's a formula I wouldn't expect my students to know. I probably would have provided it for them. Obviously, this exam does not provide it, though, so make sure you know it if you're actually taking the JEE Mains. All right, so that means we can rewrite this as just pi. The radius is x in my drawing, and then x squared plus y, square root of x squared plus y squared is L. All right, what more information do we know? We know a lot. We know that the tan of theta is 3/4, which means that the ratio, tangent is opposite over adjacent, so the ratio of x to y is the same as 3/4. And from there, I'm going to say that x is 3/4 y. Because y is the height, and I don't know, we're given the height, so I feel like it makes sense to solve this thing in terms of the height. That's why I chose to do that. I want to get rid of the x's in my problem and make them all y's. All right, I know dv dt, so I think I should start with volume. Volume is 1/3 pi r squared h, but r is x and h is y, so we have this. We figured out that x is going to be 3/4 y. So pi over 3, and then the quantity 3/4 y squared times y. Simplify this. So this, at this point, is a pretty standard related rates problem. I'm going to take the derivative with respect to time. So that's going to give me 9 pi over 16 y squared dy dt. I need to know what dy dt is. I know what dv dt is, and I actually know that y is going to be 4, because that's the way we set up the problem. So 6 is equal to 9 pi over 16, 4 squared dy dt. The 16 and the 4 squared cancel, so you just end up with dy dt is 6 over 9 pi or 2 over 3 pi. And that would be in meters per hour. We don't really need the units on the intermediate answer, but it's always good to put them. So we know dy dt. We're not actually trying to find that though, right? We are trying to find ds dt. So we know s is pi x root x squared plus y squared. We also know that x is 3/4 y, and we just figured out dy dt. I'm going to take all of that to the next page and solve basically this problem now. So let's change s so it's a function of y instead of a function of x and y. So our x is 3/4 y, so x squared is 9 over 16 y squared. There's a lot you can do with this, in particular that radical. So 3/4 y, I can take y squared out of both things in the radical, and then the square root of y is, square root of y squared is y. And then in the radical, you have 9 over 16 plus 1, which is 25 over 16. And then the square root of that is 5/4. So overall, we can do 3 pi over 4 y, 3 pi over 4 y squared times 5/4. Simplify this. We're basically done with this problem at this point. Like, you probably jumped ahead. All right, ds dt. So ds dt is going to be 15 pi over 8 y dy dt. We know what y is. We know what dy dt is. We're plugging in. So we'll say at these values. And so I don't know, like the place where I'm pulling the problems from says that the exam is online. So I assume that like your work is not graded and you just like do the work. AP exam, obviously all of your work will be graded if it's free response, and then if it's multiple choice, you know, you should still do high quality work, but your work is not graded. It's only your answers. I got 5. The units on this are going, they actually gave them to you in the problem if you look back at it, but it's meters squared per hour. Okay, that was a good one. Good related rates problem. All right, let's look at one more. So my solution differs from what the website where I got these, and I'll put that in the description. It differs from the solution that they have. The numerical value is the same, but like my reasoning is different. And I kind of think that they're wrong, but maybe somebody can correct me. So we're going to let m and n be the number of points on the curve y to the 5th minus 9xy plus 2x equals 0, where the tangents to the curve are parallel to the x-axis and y-axis respectively. Then the value of m plus n equals. So this is the kind of thing, as I mentioned, they don't do that kind of thing really on the AP exam all that often. It's more like straightforward, one concept at a time. These problems, what I love about them is they tend to mix a lot of concepts. So let's see what we can do. We need to find the derivative, right, to be able to talk about vertical or horizontal tangent lines, because that's essentially what the problem's about. So here goes. It's going to be 5y to the 4th dy dx. And then we're doing a product rule. So I consider the first function to be negative 9x. So it's first negative 9x. Derivative of the second is dy dx. Plus second is y. Derivative of the first is negative 9. So minus 9y. Derivative of 2x is 2. And then that should equal 0. I'm going to solve for dy dx. So it should just be 9y minus 2 over 5y to the 4th minus 9x. Okay, now let's think this through. If we're going to be parallel to the x-axis, which looks like this, dy dx is going to have to equal 0. I basically need to draw the picture because I, in my mind, confuse horizontal and vertical like all the time. So I recommend it, but you may not suffer the same difficulties. So dy dx is 0, which means that the numerator of this thing should be 0. 9y minus 2 is 0, which means that y would have to equal 2/9. Okay, so now we need to figure out the x value that goes with 2/9, because we need to make sure that there's a point on the curve where y is equal to 2/9, and this is where I think we get into trouble. So we're going up here, we're going to plug in. I get 2/9 to the 5th minus 9 times x times 2/9, and then plus 2x is equal to 0. But this gives us 2/9 to the 5th minus 2x plus 2x equals 0. which means we're claiming that 2/9 to the fifth is equal to 0, and that is not true, which means that there are no solutions for this, which means there are, what are we looking for? There are no points, right? So that means that m, the number of points where the tangent line is horizontal, is 0. There are none. So this is a 0. That differs from what the website had. I don't know. I think that I'm right on that. Let's continue on. So if we're going to go parallel to the y-axis, that would mean dy dx has to be undefined. For dy dx to be undefined, we need the denominator of dy dx to equal 0. So we're saying 5y to the fourth minus 9x is equal to 0. All right, so that means that 9x is 5y to the fourth, but it also means that x is 5/9 of y to the fourth, and we kind of need both of those to plug in, because if you look at the equation that we have, there's a 9x in it, so I can just substitute straight into that. So that's what I'm going to do. So I got y to the fifth minus 5y to the fourth times y plus 2 times the quantity 5/9 y to the fourth is 0. This cleans up a little bit. I don't know. I mean, a bit. And then you can factor out a y to the fourth. So I did that. And I get this. And then we can set this equal to 0 and solve. So either y is equal to 0 or y is equal to 10 over 36. So 5 over 18. Okay, we need to figure out if there are points on the curve where y is equal to 0 and y is equal to 5 over 18. So we're going back to the curve. If y is equal to 0, you basically just end up with 2x equals 0, so x is 0. That is 1 point. So there is a point where this is true. The vertical line there would be x equals 0. Now we need to take 5 over 18 and plug it in for y, and nobody wants to do that. I mean, maybe somebody wants to actually work it out, but let's just think it through, right? This is a linear function. You have like 5/18 to the fifth, whatever that is. Negative 5 halves x plus 2x. There's still an x. So this definitely has a solution, and only one solution. So 0, 0 is a solution. Whatever the heck you get out of this is a solution. That means that n is equal to 2. So if m is equal to 0 and n is equal to 2, and we are looking for m plus n must be equal to 2, which is the same answer that they had on the website, but their reasoning was very different from mine. So I don't know. I think that my logic works out, but if somebody disagrees, let me know in the comments. That would be pretty good. Anyway, I hope this was helpful, and good luck.